For our last section of Chapter 1, we're going to talk about infinite limits. We have two major objectives in Section 1.5, which are to determine infinite limits from the left and from the right, and to find and sketch the vertical asymptotes of the graph of a function. So again, infinite limits, we talked about it very briefly, and I said, hey, we'll come back to it. Well, this is us coming back to it. We talked about the fact that if f of x increases or decreases without bound as x approaches c, it's called an infinite limit. So it's important to know that though we're going to say the limit is infinity or negative infinity, in reality the limit just fails to exist, but we're going to write it as infinity or negative infinity since it doesn't follow the definition of a limit. So again, back to our tables, which I know you probably hate as much as I do, but again, if you make a table, say for the function 3 over x minus 2, we can see that f of x is going to decrease without bound as x approaches 2 from the left, and increase without bound as x approaches 2 from the right. So again, I'm not going to go through that table with you because we talked about it in detail, I believe, in section 1.2. What is easier to see is, of course, if I look at the graph of that function, I can see at the point x equals 2, this function from the left goes towards negative infinity. This function from the right goes towards positive infinity. So if I were asked, in this case, to find the limit as x approaches 2, this one actually would be does not exist. However, if I were asked to find a one-sided limit, I would use negative infinity for approaching from the left side or positive infinity for approaching from the right side. And again, this is just writing it a little prettier. Just as we talked about before, from the left side, that function decreased without bound, meaning it's going on forever and ever in the negative direction, and so we would write it as negative infinity. Again, even though in reality the limit fails to exist because it doesn't meet our definition of a limit, we're still going to be more specific and say that it diverges to negative infinity or from the right-hand side to positive infinity. So here are two limits that I would like for you to try. And notice I haven't put these with the limit as x approaches whatever, because what I'd like you to do is first to determine at what point, what is the number c that's not in the domain, which should be pretty straightforward. And then I want you to find the limit as x approaches that value from both the left and the right. Feel free to use your calculator to help you to verify if it's positive infinity, negative infinity, or if it's in fact an actual value. So press pause, try that, and then press play to see how you did. So for my first one, again, it should be pretty straightforward, finding that x minus 4 cannot be 0. Therefore, x cannot be 4. And essentially what I wanted to do then was find as the limit approaches 4 from the left, or as the limit approaches 4 from the right, what are the limits? So again, obviously this limit fails to exist, but as I approach 4 from the left, notice this is going down forever. It's decreasing without bound, therefore that limit is negative infinity. Whereas if I'm approaching 4 from the right-hand side, that function is increasing without bound to positive infinity. Same thing for b. I would like for you to find where the limit will fail to exist, and that would be x plus 2 cannot be 0, or x cannot be negative 2. And again, graph it. So as I can see here, if I'm approaching negative 2 from the left-hand side, my function is decreasing without bound. And if I'm approaching from the right-hand side, it's decreasing without bound, so negative infinity.